Hey St. Mary grade 8s, Mr. McHenry back for another math lesson. Hope everybody's doing well. Today we're going to be focusing on solving equations algebraically. And one of the things that we're going to be looking at is that when we were solving equations with algebra tiles, most of the equations had solutions that were whole numbers, i.e. a positive integer. So the solution was x is equal to 2, x is equal to 5. However, when we solve equations algebraically without tiles, we will solve equations where the solution could be a positive integer, could be a negative integer, could be a fraction, or the solution could be a decimal. However, we will be doing many of the same things to solve equations algebraically as we did to solve equations with algebra tiles. So if you took the time to go over that lesson, to do those practice questions properly, you're in a really good position because we're just going to be doing a lot of the same things. It's just that we're not going to be using tiles now. So some of those same things is that we're going to use a variable. Okay, and we talked that a variable is a letter or a symbol representing a quantity that can vary or change, and we often use the italicized letter X, okay, as our variable, and that's what we're going to be solving for. And we want to remember that this italicized X does not mean multiply. We're going to look to create zero pairs, but we're going to be doing that with integers and variables versus unit tiles and variable tiles. And one of the things that we're going to be hearing about today is using the inverse operation. We know that an equation is a statement of two algebraic expressions are equal. So something like 3 plus 2x is equal to 4. We have an algebraic expression on this side. That is equal to an algebraic expression on this side. And this goes to the important point that this is balanced. They are equal. And in order to maintain that balance, we have to make sure that whatever we do to one side of the equation, we must also do to the other side of the equation. And the last thing that that will be the same is that to solve the equation, we want to isolate the variables. So instead of isolating the x tiles, we're going to isolate the variables on one side of the equation by getting all the variables to one side. Could be the left side or it could be the right side. And we want to get all the integers to the other side. So once we have all the variables on one side and all the integers on the other side, then we can solve for 1x or x, and this is the same. Okay, there's a 1, an assumed 1 there, okay, and we want to solve for one variable. So let's do some examples. So in example 1, we have a problem. 3 more than 2 times a number is 4. What is the number? So we want to write an equation to represent this problem. We want to solve the equation algebraically, and we want to verify and check the solution. So we have this problem here, and there's some keywords in this problem, okay, that we want to focus on so that we can write an equation. So 3 more. What type of word is more? Well, more is an addition word. Okay. More than 2 times. Well, 2 times is multiplication. Is means equals. Okay, so using that, I can write an equation to represent this problem. 3 more, so 3 plus, then 2 times a number. So 2 times, now I'm not going to write that times symbol in there, but 2 times a number. Oh, and before I even do this, I need to do something. I jumped ahead. We need to write something down. We need to, and that's a good mistake for me to make, to show you we need to write something down. And that important thing is we are going to say let x represent the number. Okay, so the number that's in this problem, we're going to let x represent it. So now I can start with writing an equation. So again, 3 more, so 3 plus 2 times a number. So 2, and remember there's an itty bitty x in here, so 2 times a number. What are we letting, what's representing the number? Well, we're letting x. So 2 times a number is equal to 4. Okay? Or you could have written it as also 2x, so 2 times a number plus 3 is equal to 4. So either way is good to write an equation to represent this problem. All right, we have our equation now, and the next thing that we want to move on to is that we want to solve the equation algebraically. So I'm going to solve the equation algebraically using this equation. So 3 plus 2x is equal to 4. And the first thing we want to do is we want to isolate the variables on one side. And again, we want to look at this equation and say, where are the most positive variables? Well, there's only variables in this equation on the left side. So we're going to isolate the variables on the left side. So in order to isolate the variables on the left side, what do I have to do? Well, I have to remove the 3 here. And how am I going to go about removing this 3 on the left side? Well, I'm going to use the inverse or opposite operation, which is the same as making a 0 pair. And the inverse of, and remember this has a little positive in front of it, okay? The inverse of positive 3 or add 3 is negative 3 or subtract 3. So I'm going to subtract 3 from the left side. But whatever I do to one side, I must also do to the other side to keep it balanced. So I'm also going to have to subtract 3 from the right side. So I'm going to go ahead and do that. So I have 3, and that's that little plus 3. Okay, I'm going to put minus 3, subtract 3, plus 2x is equal to 4. But whatever I do to one side, I must do to the other side. So I have to subtract 3 on this side to keep it balanced. And the next thing I want to do is I want to simplify. Well, here, what I've done by using the inverse operation is I've created a 0 pair. So these cancel out, okay? And on the left side, I'm left with 2x. And I simplify on the right side, and I'm left with 1. So I look at my equation and I say, are all the variables on one side and all of the integers on the other side? And I can say, yes, I have accomplished that. So now I know that 2x is equal to 1. But we don't want to know what 2x is equal to. We want to know what 1x is equal to, or what x is equal to. So how do I go about solving for x? Well, remember that there's an itty bitty multiplication sign in here. So this means x multiplied by 2. So to get 1x, we do the inverse or opposite operation, and the inverse of x multiplied by 2 is x divided by 2. So we are going to do that. So we are going to divide 2x on the left side by 2. But remember, in order to keep things balanced, we also have to divide the right side by 2. So we must divide 1 by 2. So I'm going to go ahead and do that. So I have 2x, and I'm going to divide it by 2. Remember, this line here means divided by. And I'm going to do the same on the right side. Okay, and I'm going to simplify, and remember, this means divided by, so we look at the numbers here, and 2 divided by 2 is equal to 1. So I have 1x, or x is equal to, and 1 divided by 2 is equal to a half. So now I know that x is equal to a half. But I want to verify or check my solution. So I'm going to go and do that now. So I write out my equation. 3 plus 2x is equal to 4, where x is equal to a half. And I put here left side is equal to right side. A little squiggly down the middle, and I write equals 3 plus 2x. And on this side I write equals 4. Well, I don't have to do anything on the right side because it already equals 4, so I'm just going to work on the left side here. So what do I have to do here? I have to substitute x is equal to a half. So that will be 3 plus 2 times a half. Remember, these brackets mean times. Okay, so I can go here, 3 plus 2 times 1 is 2, and it's over 2. And this 2 divided by 2 is equal to 1, so 3 plus 1 is equal to 4. So now I can say, therefore, the left side is equal to the right side. Therefore, x is equal to a half. Okay, we're going to go and do another example. This one's a little bit of a word problem. So we have here, Julie's mother is 4 more than 4 times her brother's age. Julie's mother is 48 years old. How old is Julie's brother? So again, we want to write an equation to represent this problem, solve the equation, and verify the solution. So I'm going to write an equation to represent this problem, and this time I'm going to start with, I'm going to say let, and I'm going to use the variable x again. You can use any letter you want. In some questions they're going to use n or y, okay? It's the same, they just have chosen a different letter for the variable, but most times it's going to be x. So let x represent, and what are we solving for? Well, we're solving for how old Julie's brother is. So let X represent Julie's brother's age. Okay, so now we can go in. So this is going to be what X is. All right, so now we can look at this equation again and write on it. Okay, so Julie's mother is, well, we know is means equals. 4 more, well, more means add. Then 4 times means multiplication. Her brother's age, well, we said her brother's age is going to be X, so this is going to be X here, okay, the italicized X. Julie's mother. Okay, well, what is Julie's mother? Well, Julie's mother is 48 years old, so we're going to put 48 up here. So now we can write an equation and we can say 48 is equal to 4 plus 2x. Okay, or you could have written it as, if you did it a different way, that's fine. 4 plus 2x is equal to 48. Either way is okay. So now we've got an equation to represent this problem, and we're solving for the unknown, which is represented by the variable x here. So we're going to go ahead and solve it. So we have 48 is equal to 4 plus 4x. Okay, so I'm going to look at this and I'm going to say I want to isolate for the variables. And where are the most positive variables? Well, the most positive variables are on the right side this time. So I'm going to isolate the variables on the right side. And how do I isolate the variables on the right side? Well, I need to remove this positive 4x. Okay, if there's no negative sign there, it's just the integer, it's assumed that it is positive. And how am I going to remove this positive 4x on the right side? Well, I am going to do the inverse or opposite operation, which is the same as making a zero pair. And the inverse of positive 4 is negative 4. So I'm going to subtract 4 from the right side. But we know whatever we do to one side, we must also do to the other side to keep the equation balanced. So what do I need to do to the left side? I also need to subtract 4. Okay, and one of the things that you're going to notice while I'm doing this is, see, my equal sign goes right down the middle. It stays right down the middle. That's good format for math. All right, so now I'm going to simplify. And I see here that I've created a zero pair. Okay, so that's going to equal 0, so we don't write in the 0. Okay, so we just bring down the 4x. And on this side, we simplify as well, and I have 48 minus 4 is 44. So I look at my equation. Do I have all the variables isolated on one side? Yes, because I have 4x. Do I have all the integers on the other side? Yes, I do, 44. So now we know that 44 is equal to 4x, or 4x is equal to 44, but we don't want to know what 4x is equal to. We want to only know what 1x is equal to. So how do I go about solving for 1x? Well, remember what this means. It means x multiplied by 4. So to get 1x, we use the inverse or opposite operation. And the inverse of x multiplied by 4, or 4x, is x divided by 4. Okay, or x over 4. So I'm going to take this and I am going to divide this by 4. But we need to remember to keep it balanced. Whatever we do to one side, we must do to the other. So if I've divided the right side by 4, I must divide the left side by 4. And remember, this line here means a lot of things. In this case, it means divided by. Okay, so we're going to simplify, and 4 divided by 4 is equal to 1x, and 44 divided by 4 is equal to 11. So 1x is equal to 11, or if you don't like writing the 1 in there, you can just say x is equal to 11. Okay, one last example to go through here. Oh, before I do that, I need to verify my solution. So I need to go 48 is equal to 4 plus 4x, where x is equal to 11. And I put here left side is equal to right side. And I put a squiggly where the equal sign is. And on this side I put equals 48. So there's nothing else I need to do there. On this, the right side, I put 4 plus 4x. I'm going to substitute x is equal to 11 in, and when I do that, I get 4 plus 4 times, remember these brackets mean itty bitty times in there, so I use my bedmass rules, multiplication before addition, 4 plus 44, I add these, 4 plus 44 is equal to 48, therefore left side is equal to right side, therefore x is equal to 11. Okay, I have a last example here, and this one has a little bit of a wrinkle in it, in that we're going to have variables on both the left side and the right side, and it's the same as when we use the tiles. Okay, so we're going to go, and it says here 4 times a number minus 6 is equal to 2 times the number plus 4. Okay, so we are going to write an equation to represent this problem. We're going to solve the equation and we're going to verify the solution. So write an equation to represent this problem. The first thing we're going to say is we're going to say let x, okay, represent the number that we're solving for. So 4 times a number, well that's going to be x. Okay, 2 times the number, well that's going to be x. Okay, we can go into here and we can say 4 times. Well that means times means multiplication, and minus 6. So subtract 6 is equal to 2 times, that's multiplication, plus 4. All right, so now we can write an equation out. So we say 4 times a number, okay, and remember that we're going to write it as 4x, okay, where x is the variable and there's an itty bitty times in there. And we usually don't write that multiplication in there, but if you need to, just write it in itty bitty in there, okay? And then we say minus 6 is equal to 2 times, again, 2 times the number, okay, we'll let x represent that number, plus 4. So now I've written an equation to represent this problem. You can see that in this equation we have variables on both the left side and the right side. So we're going to go ahead and solve the equation. So we have 4x minus 6 is equal to 2x plus 4. And I look at this equation and I say to myself, where are the most positive variables? Well, the most positive variables are on the left-hand side. So I want to isolate the variables on the left-hand side. Get all the variables to the left-hand side. So in order to do that, I need to get rid of this 2x on the right-hand side. So how am I going to go about removing this 2x? And remember, there's a positive in front of that positive 2x. Well, I'm going to use the inverse or opposite operation, which is the same as making a zero pair. And the inverse of positive 2x is negative 2x. So I'm going to put that in here. 2x minus 2x plus 4. But whatever we do to one side, we must do to the other to keep it balanced. So I'm also going to write that on the other side. 4x minus 2x minus 6. And now I am going to go about simplifying this. And on this side here, we see that 2x minus 2x, well, that's a zero pair. So on the right side, I'm going to have 4. So I bring down the 4 here. On the left side, I have 4x minus 2x. Well, 4x minus 2x is equal to 2x. And I continue to have the negative 6 there. So I look at my equation and I say, have I isolated all of the x's by themselves on one side? And I say no, because I have x's on the left side, but I also have some integers. So I only want to have x's, or the variables, on the one side, on the left side. So now I have to get rid of this negative 6. So how am I going to remove the negative 6 on the left side? Well, I'm going to remove it by using the inverse operation, which is the same as making a zero pair, and the inverse of negative 6 is positive 6. So I'm going to add positive 6 to the left side. But in order to keep everything balanced, I must also add it to the right side. So I add it to the right side. 4 plus 6. And I simplify. And here again we have a zero pair. And we bring down this 2x. On this side we simplify, and 4 plus 6 is 10. So now I look at my equation and I say to myself, do I have all the variables isolated on one side? Yes. And I also have the integers isolated on the other side? Yes. So now we know 2x is equal to 10. We don't want to know what 2x is equal to. We want to know what 1x, or what x is equal to. So when I look at this, remember that what this means is that x is being multiplied by 2. So in order to get 1x, we need to do the inverse operation. And the inverse of x multiplied by 2 is x divided by 2. So we are going to divide 2x by 2. But in order to keep everything balanced, we also, whatever we do to one side, we must do to the other. So I must also divide the right side by 2. So I divide 10 by 2. And now I go and simplify. And 2 divided by 2 is equal to 1x. And 10 divided by 2 is equal to 5. So 1x is equal to 5, or x is equal to 5. And I am going to go and verify that solution. So I have 4x minus 6 is equal to 2x plus 4, where x is equal to 5. So I have my left side is equal to my right side, and I put a squiggly down the middle, and on the left side I have 4x minus 6, and on the right side I have 2x plus 4. Just going to work on the left side first, so I'm going to substitute x is equal to 5. I substitute that in, so it's 4 times 5 minus 6. Again, these brackets mean that there's an itty bitty times in there. So it's 4 times 5 is 20 minus 6. 20 minus 6 is 14. On the right side, again, I'm going to substitute in x is equal to 5. So it's 2 times 5 plus 4. Using my BEDMAS rules, 2 times 5 is 10 plus 4 is equal to 14. So therefore I do have the left side is equal to the right side, and therefore I know x is equal to 5. Now, if I had done my verification check and I did not have left side equal to right side, I made an oops somewhere, and I need to go back into my work and I need to review my work, check where my oops was, find a new solution for x, and then come and verify the solution again, and hopefully there I found my oops and that the left side equals the right side. Now, again, some of the questions in the practice are going to look simple to you, and some of you will be able to look at the questions and use mental math or guess and check or some other type of strategy to solve the equations. That is not what the goal is here. The goal is that you are working on solving equations algebraically, that there's a process to this, that you need to show your work, okay, with that process. And again, if you are not doing that, you are cheating yourself, and it will come back to haunt you later on in your math career, i.e. next year when you are in high school and taking math. So please, put in the time now, get that background knowledge so that when you go into high school math for next year and you see this, you can activate your background knowledge and you can feel confident that you are going to be successful. All right, please check D2L for the lesson and also for the practice questions.